First, let's try to derive the law of cosines. So right now, let's talk about the law of cosines. And first, let's have a triangle positioned in a rectangular plane with the vertex of the angle alpha at the origin and the side AB on the positive x-axis. So let me draw the sketch. And if this angle alpha is an acute angle, then we have the triangle like this. So this is the point A, which is the vertex of the angle alpha. And then this point B, and this point C. So now we use the x and y for the coordinates of this point C. And the side of this, okay, the length of this side opposite the angle beta, we use the B for this length. And then the length of the side opposite the angle alpha, we use A. So this is the C, which is the length of the side opposite this angle, okay, gamma, that is angle ACB. So right now, let's draw the attitude from this point C to this bottom line. Then you know this is the x, right? And then this guy is the y. Okay, since this C is in the quadrant 1, so we know both x and y are positive. So this is the case when the alpha is an acute angle. If the alpha is an obtuse angle, then we have the picture like this. And this point A, which is at the origin, and then point C, whose coordinates are the x and y, and then this is length A, and then this point B, okay, since this is the length C, so the coordinates of the point B should be equal to C0. Same thing here, okay. The coordinates of this point B is C0. Now, after we draw the sketch of this triangle in these two cases, then let's use the trigonometric ratio theorem, okay, which is on the section 5.6, okay, from the, okay, it's on the page 488, section 5.6. Okay, we will use that trigonometric ratio theorem and then we know sine alpha in either case is equal to the y coordinate over the length of this, okay, hypotenuse. So that is a y over b, right? And cosine alpha, which is equal to the x coordinate of this point C over this length of the hypotenuse, that is the b. So in this way, we can express the coordinates of the point C in terms of the B and alpha. So from here, we have the x equal to B times cosine alpha and y equal to B times sine alpha. So now we try to express the length A in terms of the B and the C and the alpha. Since this A is just the distance between the point B and point C, right? So we can use the distance formula to find this length. So the length A, which is equal to the length between the point B and C. So by the distance formula, this is equal to square root of the x minus c, and then plus square plus the square of the y minus 0. So now we plug in the expressions for the x and y into this expression, then we get B times cosine alpha minus c square and plus the square of y. So that is a b square plus sine square alpha. Now let's move to the next page. So that means from this expression for A, we can square the both sides, and then we get the x squared equal to the square of the b times cosine alpha minus c, and plus the b squared times sine square alpha. So now let's square this both sides. So we have the a squared equal to the square of the b times cosine alpha minus c. Okay, I just copied the result from the last question. And plus b squared times sine square alpha. Now we can expand the right side. So by using the square of the binomial formula, we got b squared times cosine square alpha minus 2 times b times c, and then times cosine alpha, and then plus c squared, and then plus b squared times sine square alpha. Now you combine this b squared and times cosine alpha squared and this b squared times sine alpha squared together. So by using the fundamental identity, you have the b squared times cosine square alpha plus sine square alpha, and then minus 2bc and times cosine alpha and plus c squared. So now by the fundamental identity, we know this cosine square alpha plus sine square alpha is equal to 1. And then we get b squared minus 2bc times cosine alpha and plus c squared. So now, in this way, we get the first formula in the law of the cosines. That is the a squared plus b squared minus 2bc times cosine alpha plus c squared.